Well, this is just a little update on what we started off the other day, showing the notes that I took on topic 2.4. Remember, we skipped 2.3, and page 1, you may recall, were the notes for the first 10 minutes, as we indicate there. And then what I did is I finished it up today, so we have notes for page 2. And again, what I did is I watched the video carefully. Now, I didn't take notes per se on the video, but I took questions from the notes that you might take, and then later would ask these in a quiz. So picking up where we left off, this was page 2 now. We're looking for t-charts of the values for e, the function of e to the x power, which is indicated right here. And then what would the graph of this look like? Well, very similar to 2 to the x power. But remember, e was about 2.7. Okay, and then we had some others, and we're pointing out that as the number from, let's say, 2 to 2.7 or 3, this curve gets closer to the y-axis here. Then we looked at the compound, or the formula for compound interest, which was here. And then we worked an example. And then the formula for continued interest and an example. And then a formula for exponential growth, which is listed here. And then on to page 3. And this is sort of significant here. We wanted to compare exponential form, which is b to the y power equals x, to logarithmic form, log of b of x equals y. And we went through that, and we asked for examples, and this little formula, the base to an exponent equals an answer. That's what this refers to. Converting it to logarithm, the log of a base of an answer is equal to the exponent. And we gave an example, 3 to the second power is equal to 9, where the log of 3, the answer is 9, the exponent is 2. So again, that you're allowed to use your notes, I would ask a question about this. And then we compared the graph of a log function here to the graph of an exponential function. This was the typical graph up here, while this was the graph of the log. And we talked about the axis of symmetry, which is the equation y equals x. And if we folded this paper along this axis, these would self-impose on the other. And then we said, how about if we graph where instead of being a whole number, it's a fraction to an exponent. And we said this line comes down opposite to this line here, and here the axis of symmetry is the x-axis, and there is still a vertical asymptote, in this case the y-axis. Okay, we talked about the domain. We then graphed the natural log, and instead of going through a 2 here, goes up to about a 2.7. Okay, and we mentioned something about it, which is a very important thing. When you have natural log of e to the k power, this always ends up being just the value of k. And here we are at 32 minutes. And then on to page 4, where we went to doubling time, and then half-life. And that brought us to 39 minutes. And then we just took a very few moments to go over the examples that are in the book. So again, these are potential questions based on your careful study and note-taking of your flipped classroom homework. And we'll wrap this up so it's not too long.